So this is what we do, okay? If it's incompressible, that is, if it's something that doesn't compress, and by the way, we pretend that the air isn't compressible, even though it actually is. What happens is if we have a restriction, everybody knows that the fluid is going to speed up in that constriction. It's kind of like when you put your finger over the end of a hose. The air will speed up through that little constriction. If you make the area smaller, it'll squirt out faster. Okay, and the reason for that is that the flow rate, the cubic meters per second, right? The cubic meters per second here have to equal the cubic meters per second there, right? Cubic meters per second. So otherwise, this is assuming you don't have a pipe that leaks, right? Okay, so what you can do then is you just set up area 1 times velocity 1 equals to area 2 velocity 2. This is the flow rate here equals the flow rate here, right? And since the pipe is smaller, the velocity will be bigger, right? This area is smaller, this velocity will be bigger. Okay, so a 12 centimeter inner diameter pipe with water flowing at 1.18 meters per second narrows to 5 centimeters. What is the velocity in the narrow part? What is the volume flow rate? Okay, so we'll figure this out. Okay, so we're just going to say area 1, velocity 1 is area 2, velocity 2, right? So inner diameter pipe. Okay, so our first area, this first area here, I'll call this area 1, right, is going to be pi times 0.06 squared, right? This is area 1. I'm just using pi r squared. That's the cross-sectional area. And it's flowing at 1.18. That's V1, right? Meters per second. This is meters, right? That equals, okay, so it narrows to 5 centimeters. So that is going to be, area 2 is this guy here, right? Area 2 is going to be pi times 0.025. And again, this is 5 over 2 divided by 100, right? By the way, you can get away with like forgetting that sometimes, right? And then we're going to go V2, right? Okay, so notice that the pi's cancel. I don't even need to use them. So I'm going to go 0.06 squared times 1.18 divided by 0.025 squared. And I get that V2 is 6.7968, which if we had 3 sig figs, we'd have to round to that place. We'd have to say 6.80 meters per second. So it's going considerably faster, right? And that's because the area is smaller. And then it says, what's the volume flow rate? I guess I'll just use this. I can't ignore the pi now, right? So the volume flow rate is just A1 V1, right? So it's pi times 0.06 squared times 1.18. So pi times 0.06 squared times 1.18 is equal to a whopping 0.01334, and that's cubic meters per second. But again, remember it's like 13.3 liters per second, so it's not nothing, right? It just, when we do it in cubic meters, it looks ridiculously small. There you go. All right, enjoy. I never know what to say at the end of videos.